Earth's equator, if you extended it out to the sky, there's a line on the sky that corresponds to Earth's equator. That's called the celestial equator.
All right.
Okay.
That's cool.
Now, there's another line that crosses the celestial equator. So think of it as two rings at an angle to each other.
Right.
This ring crosses the celestial equator at an angle of 23.5 degrees.
Okay.
23.5 degrees.
23.5 degrees.
That line is the path throughout the year that the sun takes against the background stars. Why is it 23.5 degrees?
Because we're tilted that way.
That is the tilt of Earth.
Okay.
And because we're tilted,
right,
the sun doesn't line up with our equator. The moon, in its path around the Earth, has its own
line.
Its own line. That's angled 5 degrees to our ecliptic. If the moon is crossing the path of the sun, at the same time the sun is in that spot, you get what?
An eclipse.
An eclipse.
Right.
So this path the sun takes around the Earth is called the ecliptic. How far does the sun go every day along that ecliptic? All right, how many days are in a year?
365.
How many degrees in a circle?
360.
Ah!
Look at that.
The sun goes approximately a degree a day.
Right.
So in a month, it goes a degree a day. It goes 30 degrees across the sky.
Okay.
Just add all that up. Okay. So more lines. I ain't done with you.
Wow. It's got more lines than the damn subway.
Okay, you ready?
Go ahead.
Earth's longitude and latitude.
All right.
You can project that onto the sky and have a grid system on the sky.
Right.
We have that. And our longitudes become what we call right ascension, and the latitudes become what we call declination.
Okay.
Okay. And right ascension is measured in hours, and the declination is measured in degrees. So every object in the sky has a coordinate in right ascension and declination. So if you look at a star map, you'll see this grid.
Right.
That's how we know where anything is.
Right.
That's how we tell a telescope to find something on the sky.
I was going to say that's when you look up and you find any celestial body in a telescope.
In a telescope,
they say,
it's got coordinates. Except we have hours for our right ascension. Here, our longitude is still in degrees, but we could have measured it in hours because it's 24 hours around. We just didn't.
Okay.
Okay. All right. So now, the North and South Pole have spots on the sky.
Okay.
You get the North Celestial Pole,
mm-hmm.
the South Celestial Pole. The North Celestial Pole is near Polaris, the North Star.
Okay.
It's not actually pointing to Polaris. It's like 2 full moons widths away from it. So it's just kind of near it. And people say, oh, we have a pole star. There's something divine about that for our navigation. And no, it's just sort of near it.
Sort of near it.
Earth, tilted and spinning on its axis, tugged on by the moon, actually wobbles.
Uh-oh.
Okay. It wobbles.
What happens to all these lines?
I'm about to tell you.
Oh, my God.
Watch. Here you go. You ready?
Go.
Okay. So the North Celestial Pole precesses in a circle on the sky.
Right.
Once every 26,000 years.
Oh, my God.
Okay.
Like a black girl's head bob.
What's
mm-hmm.
Mm-hmm. So the North Pole traces a circle on the sky once every 26,000 years.
Wow.
All right. Which means the North Star, Polaris, only happens to be our North Star now. In the days of the Egyptians, 5,000 years ago, it was not pointing to the North Star.
Right.
I think I got to check my notes. It was pointing to a Thuban. There's some other star, which was the pole star for the Egyptians.
For those guys, right.
Okay? Different pole star.
Wow.
All right. There's a 26,000 year cycle. Okay? And it drags our grid with it.
Okay.
Because our grid on the sky emanates, it matches the grid on the Earth. But how about the stars? What coordinate are they if we're dragging the... So this freaks people out if they hear it for the very first time. Every coordinate we have for objects in the sky have a date. That is the coordinate they had at that date.
Oh, wow.
So we all agree. Are we referencing the year 2000?
Right.
January 1st at midnight? You give the coordinate and you give a date. Then you hand that to your telescope, which is talking to a computer, and the computer says, let us precess the coordinates of your object from that date that you gave it to tonight.
Wow.
From the year 2000 to the moment you were observing that object. So the grid system is not constant.
Right.
It's crazy.
That's insane.
Yeah, and before we had computers doing this,
somebody had to do it by hand.
Yes.
Oh my God.
We had to process the coordinates by hand using something called spherical trigonometry.
Wow.
And it used to be an entire graduate course in astrophysics. And I got into graduate school just when the computers started taking this over.
Right.
And the name of the guy who wrote the book on spherical trigonometry, his name is Smart.
Well, guess what? He's dumb now. All them royalties dried right up.
Now, a consequence of this grid shifting is that the constellation in the sky that the sun was in at that month of the year has also shifted.
Right. No.
Up. So 2,000 years ago,
exactly,
when they're laying out the constellations that the sun moves in front of, and they decided there's 12 of them, and they called them the zodiac because there's animals at zoo. The zoo is the key.
Right.
The key.
The zodiac.
The zodiac. Okay. They were all lined up for astrologers 2,000 years ago. So 2,000 years ago, when all these were laid out and the boundaries and the houses and everything, what percent of 26,000 is 2,000 years ago?
2 times 13, so 113.
It's 113,
right.
Which is not that far from 112.
Right.
Okay?
Okay. Oh!
This is my saying! This is what I'm saying.
That's where we go.
So all these constellations are shifted by a whole constellation along the zodiac.
That kind of messes up the whole premise, though, doesn't it? Like,
you telling me? You telling me that?
I'm like,
I'm just, okay. So
if I'm born in a certain month,
correct. The month was when the sun was in that constellation.
Was in that constellation.
It's a completely other constellation now.
Oh my God!
Correct.
Wait a minute.
What?
I'm so sorry, guys. This is worse than Pluto for you
because it got set up 2,000 years ago.
Right.
That's when it got, not in ancient Egypt, 2,000 years ago. It got set up. Everything's shifted by a constellation. Plus, the sun has another constellation it goes into, Ophiuchus. The sun passes through 13 constellations, not 12. But they didn't tell you this. So, in fact, the sun spends more time in Ophiuchus than in Scorpius.
Well, that's because, I mean, Ophiuchus is hard to say. So, Scorpius is easy.
Okay. So, if you thought you were Scorpius, you were probably Ophiuchian. And all Scorpions and Ophiuchians are currently Librans. This ecliptic, which is where you find the zodiac,
right,
is shifted against the background stars.
That's right.
It's shifted against where the sun is on the month of the year.
Right.
Chuck, thanks for being here.
Always a pleasure.
All right.